So hope you had a nice lunch. And if somebody is having that, you can still come and have a seat. We can have a session over lunch. And so we are coming to the last session of today, and we talked about Hadoop and Teradata as part of our ecosystem. We talked about the next generation data warehouse, and what we are going to talk about as part of the theme of near real-time data warehouse, which the different speakers got in the previous sessions. We are going to talk about the real-time event processing through Spark. And to facilitate that, we have Madhukara who is with us, who is the CTO and co-founder of Data Mantra, a Spark consulting company, and I was asking him to come.
Okay, am I audible? Yeah, I don't need mic normally, so that I can get more space here. Okay, so it's always difficult to do an afternoon session, that too after lunch, right? And this session don't have code now. So normally when I do a session, it's more of a code. So it's easy to grab the attention of people saying that, okay, they say if condition, this and that, but there is no code also. So I will try to see how much attention I can get from you after lunch. I hope the pizza and the soft drink is light compared to normal lunch. Right, so today I am talking about real-time event processing with Spark. Before I start, just to get an idea, like what kind of ideas we have. How many of you heard Spark? Okay, most of you. How many of you use Spark in day-to-day work? Okay, few of you. Okay, how many of you use Scala, those kind of things? Okay, few of you. How many of you use Hadoop every day? Okay, here every day means not in weekends, other days. Okay. Right, so I'm not going to go detail about Spark per se. I'm going to talk about one of the case study. I have worked with one of the customer here to just get an idea like how Spark is used in their solution and why we went with Spark compared to any other tool out there. And also one thing, I don't have a slide saying any questions. So if you have any questions, feel free to ask in between. Okay? Just to give an idea of who am I. My name is Madhukara Phatak. I run a company called Data Mantra, where we consult on Hadoop, Spark and Scala. And I do run a Spark meetup in Bangalore. Okay, just to get an idea, how many have been there earlier? Okay, so we have some people from there. And if you want to contact me online, just go to this website where you can connect with me on every site out there. Right, so you know who am I? Let's start. So today this is the agenda. So most of the people here, I think we talked about retail and telecom and different things. But one of the case studies, or most of the case studies that I am working these days, but particularly in India, they are coming from mobile world. Because what's happening here is that one of the interesting things I was thinking about now was, this place is around 2 kilometers from my place. It's very, very near. And the customer who I'm going to talk about today is around 2 kilometers from here. Right? This is more and more very, here only, everything is done in Bangalore. And also the interesting part about here is that we are talking about a company where like 5 people. Right? It's not a big company, it's a very small company, but they do have a huge data problem. The reason is mobile. Right, so we have companies these days where they have a hit application on phone where they are maybe used by millions of users, and actually the company is around 4 to 5 people. So this is the one thing I'm going to focus on, how mobile is changing, the way we look at the big data. It's no more a big companies only, it's a more and more small companies who want to do big things. And I'm going to focus on what is the customer doing. So it's not like a promotion for our customer per se, but most of you, I bet you are using their solution. We will get to that. So I'm going to talk about what kind of software they are building. And I'm going to talk about what is the existing data solution they had before I started consulting with them. Then how we moved into improved solution, and I'm going to get into some of the technical details, like what kind of tools we use, why we use, and those kind of things. Okay, let's start. Now, it is a wrong question to ask how many people have mobile phones. Let me go reverse. How many don't have mobile phone? Okay, no one. So how many of you are still not on smartphone? Okay, so everyone on smartphone. Right, so mobile has changed the way we look at big data or even the way we look at anything. Right, what is the reason? Most of the buy and sell these days happens on mobile. Right, so for example, I am giving few examples just to give an idea. Myntra went fully mobile few months back, saying that there is no reason we have to put effort on the web because only few percent of people are really buying from web. Almost everyone is buying from phone. Right, so they directly went phone. For Flipkart and Amazon, if you go and ask them, they say 50% of our sell happens on mobile. Actually, this is a very conservative number, but it's much more than what we think. The reason is simple. I am talking about Indian context. 40% of Indians are on only phone connected to internet. That is their primary device. So naturally, they want to buy through the phone itself. And if you have our Flipkart and OLX, so I talked about first two are buying experience, next two are selling experience. And most of these things are not new to you per se, right? Every day almost you are using these tools. And if you think about Ola kind of company, right? They don't even have a way to book from the web. It always phone because you have a location, maps, tracking, etc., etc. Which means these days we are looking at solution where most of them are mobile first, or even they have web presence. Slowly things are moving into the mobile world. Right. So this is one of the interesting factor we are seeing from few years. Now, why it is difficult to build mobile experiences? Right? You may think, oh, I have a web store on phone. Just put a same on phone, whatever iOS or Android. Building an application is very easy comparatively with all the SDKs, tools, etc. But building an experience is very hard. What is the reason? One of the reasons is customer expect the service to be available 24/7. Now, recently I met one Flipkart guy. So we were chatting about and saying, okay, you have a mobile application. What are the difference? They say they used to have this 2-hour downtime for after a few months just to upgrade their whatever the infrastructure, etc., etc. So they used to say, okay, night 2 o'clock to 4 o'clock, we kind of shut down most of the things and we upgrade things and we'll be back online. And nowadays they cannot do it anymore. So the idea of downtime is gone because people are even buying up at 2 o'clock. I don't know, maybe you wake up from the dream and say, oh, I should buy something now, just click. Right, so that's how it's going on. And also, tiny screen make very challenging to technical software flows. For example, think about entering, so I'm going to talk about payments after this. Just doing a payment on a tiny screen is very, very difficult. You have to enter so many things, you have to log in so many places. So if you just translate your web application to a phone, it becomes very hard. Of course, you have this network issues. Maybe most of us here have Wi-Fi in home, but most of people who are coming to this site not really coming from Wi-Fi. They are coming from 2G, 3G, maybe 4G also. And any G you have, you always have a problem with signals. Right? It do not matter which G you have. There is no signal means there is nothing. So you have a friendly connection, and also people are constantly moving, right? So you may be buying from a bus, you are maybe buying from something else. Maybe you connected to a network and everything was going fine. Suddenly you move into some other tower, everything stops, right? So you may be thinking why this is difficult, because in every these things we collect data, and most of the time the data is not complete at all, because customer moved from one tower to another tower and we just have partial data. The email just logged out, or he may not completed the things, those kind of things. And most of the things is everything has to be done real time, right? So big billion days, all those promotional things, you know, right? Everyone is there buying. I think only there are 5 TVs are out there and million people are trying to buy. And everyone thought we bought it till you gone and made a payment. And even some people told me that they made a payment also, then they got money back. Right, so which means unless the software has the way to say what is going on in the real time, the view of the world may be different for different people. So no more the idea that, okay, we will make it at a transactional level and say, oh, things are not right. That kind of things are gone when you are thinking about mobile, because it's all about scale. Now, one of the things I'm going to focus on today, particularly for our customer and data solution, is mobile payments. How many of you recharge from your phone these days? Okay. How many of you buy things from mobile? Like Flipkart, any big service. So many people, right? So you pay almost from mobile these days. And whatever the application I talked earlier, they all need mobile payments, right? So this is a very common thing. Now, getting payments right on phone is very hard, right? Every kind of app tries to reinvent their own way of doing payments, and most of the time they are broken. Now, one of the stats I got from one of our customers, they say, globally, around 21% of the shopper, they abandon their basket because of payment failures or delays. Which means I went to a website or an app, I wanted so many things, I say, okay, pay, and things went wrong, I never went back. Right, so which means there's a huge drop of actual buying, not because of your software, because of the payment systems, right? And if everyone's trying to do it, it's very hard. That's why some companies are building the SDKs, which makes the payment easy and reliable for other applications. So rather than everyone building their own payment systems, the idea here is that there are some companies say, okay, we build you the reliable payment system, you use it as an SDK, we will take care of everything else. And our customer is one of whom building these kind of SDKs. And that's where the data product comes from. So this is kind of given a context where exactly we are trying to use these things. Now, before I get into the actual data solution, let me give you like very high level view of what the product looks like and why they are into this space. Now, why mobile payments are hard? So rather than putting like lines of text, I thought let me capture in pictures. Too many inputs, right? This is where you go to Redbus or you go to Book My Show. You have so many things to fill up. Okay, can I go with a credit card, debit card? And again, credit card, debit card has this OTP passwords. There is a net banking, cash on delivery, pay you money, you name it. Every day there is a new company coming and says, okay, pay through us, we will give you 100 rupees more. Right? So you have more and more options here. And if you want to just fill up this in a form, it takes a long time. And maybe you forgot password in between, right? You may not be buying every day from every same pay you money because they don't give you offer after some time, right? So you may be buying from someone else, maybe you came back and said, oh, what is the password now? Who knows? And terrible interfaces by banks. So now this is easy to simulate. Go to Chrome and go to hdfc.com and say, render in a phone. Right, this is what you get. And just to give an idea, there's a scroll bar here. Which means some more information is there, but no one cares. And what I really want is that, okay, put a customer ID and say, let me log in. Now, interestingly, I don't know why, but most of the phone apps never go to the phone website of the actual bank. Maybe no one has figured out that. Now, this is the big dilemma, right? Do I go with the OTP or password? Now, you can say, okay, OTP is always better, right? Because you don't have to remember anything. But problem with the OTP is that there is no guarantee that it comes to me, right? So I click the OTP and say, okay, who knows what happened? Maybe it came, or maybe sometime I get 2 OTPs. Now I have to figure it out which OTP I should select because there is no timestamp per se. Right, so that they say, okay, maybe I figured out one of my password of 100 password, maybe one of them. Now I go to the password phase, and I figure out, oh, I forgot the password. Now I can't come back to OTP. Now you are just abandon it, go through the same process again, and maybe by that time you may be bought in the shop itself. Right, so these are the things making every new app to make it very difficult to sell because it's very difficult to give money. We have money, but it's very difficult to give it to someone else because so many in-between people are involved. Now, this is one HDFC Bank example I have given because this is what I use every day. But imagine you have 5 different bank accounts and trying to kind of pay by some things. Everyone has their own UI, everyone has their own flow, and they have their own things. Right? Remembering everyone where to enter what itself is a big cognitive overhead. So what this company done is very simple. I think how many of you seen this UI? If you use Book My Show, Redbus, so many things, maybe you've seen this blue things. I'm not supposed to tell the company name per se, but you can figure it out once you go home. Right, so what they do is that they say, forget about your bank UI. We will give you 2 big buttons like this where you have to press. This is easy, right? They say, okay, plus on this if you want password, plus on this if you want OTP. Any bank it works, like HDFC, whatever the bank you name, they will figure out how to do it, you just have to press. And one nice thing about this is that once you get the OTP, you don't have to find out which application really has that, because we have 4 messaging applications and maybe one of them has it. So what we do is that they read the message from you and say, okay, this is OTP. I don't know why they show it, because we don't know which is OTP clearly. But they say, okay, do you want to approve? Just click approve, your OTP is approved. Right, and I've now shown you few of the things. For example, there is a retry option. For example, I went to password flow and say, okay, not really, not today's password day. Right, then they say, okay, you maybe seems to be a problem with the password, do you want to go to OTP? They retry the flow. Right, so which means what they ultimately want to do is that, so people has to pay. And once you pay, the company who is selling it make more money, and once they make more money, this company makes more money. Simple. Right, so that's what they are building. Now just give you an idea, what they do is that mobile SDK, which helps you to do these kind of things. Nice thing is that they do it for all kind of banks and all kind of flow what you think of, right? So they are smart about it.
Is it only for Android?
I'm not sure, they may have iOS also. So what I have seen is Android only. Okay. Okay, now just to give you a number, so the company is small, but their business is not small. Right, they have around 40 plus customers here. You name like Redbus, Make My Trade, Free Charge, those kind of companies. So they are not really small. They have 1 million transactions per month as per of March. So this consulting I have done around March. There is a few reasons why I am specifying the dates also, because maybe this 1 million transaction may go on to a few million transactions because they got funding recently. So around 50% success. What I mean here? So one of this case study what they have done inside they shown is 50% of the time most of the application drop payments. Right? That's why they come to this kind of SDKs, and what they say is that they have improved this success rate 5% across different applications. Which means a company which using this SDK, they are saying we are having 5% more payments compared to they are not using. So that's kind of a way to justify why you should integrate with the third party things. Now, yeah, so everything else I have told. Now, thing is that why data matters, right? Everyone is happy, everyone is paying, right? Why data matters? One of the things is that as number of transactions increases, automatically things start going wrong. And since you are sitting in major applications, every time things go wrong, you get 40 calls. And you have only like 5 people sitting in the company. Right? You can build an SDK with 5 people, but you cannot support with 5 people. So what happens? There are so many different combinations can go wrong, which is nothing to do with application. So I will give you some example what they were facing. Airtel OTP is failing with State Bank consistently, and nothing is in your hand. Only the thing is that you have data saying that something is going wrong. Right? Now, customer is stuck in password phase forever, but you never know. Right? They may have went back and say, okay, we don't know what to do here. Not able to read from OTP from specific Chinese phone. Maybe Chinese, the way they write the SMS different. So you have all the flow, suddenly you say, oh, we cannot read OTP from here. Right? So what happens here is that when you think about a scale, even the smallest SDK, there are so many varieties of things going wrong, and these things don't go wrong one by one. So there's a saying that when you have a success, it comes only once. When you have a failure, it's a cascading effect. Right? You series of failures. So what happens is that for a company which is so small, finding out or testing all these combinations is virtually impossible. Right? You cannot test with the 40 different banks and 40 different companies and those kind of things. What they can do is that they can capture the data and react for it rather than saying we will test all these combinations. Right? So what happens is that understanding customer pain and reacting to it is very, very important, because most of the time when we do a payment, we are not just looking for a success, but we are also looking for a help. Right? We're saying that, okay, if I'm stuck in the password page and someone will say, don't worry, we'll give you an option of OTP. Or even better than that, we can say, okay, if I already know that Airtel OTP is failing with State Bank, it's better to say upfront and say, don't try State Bank. I know you are already an Airtel customer. Maybe try with other credit card or debit card or ICICI Bank or something. There are a few there are a few applications already do it. For example, if you go to free charge, they say, oh, Airtel things are failing. Don't do it now, maybe come back later. So which means upfront telling to the customer that things are wrong even helps the customer rather than fixing per se. Maybe because fixing is not in your hand, but informing and helping the customer to make a payment is very important. And why it is important? Every help results in a payment. Simple. Right? If you get an help and say this is how you have to do it, they will go ahead and do the right payment rather than being stuck in forever. Now, if you look at it, so many different combinations and understanding and giving a response is not easy. Right? Now, before I started the consulting, they already had a solution, but it is more towards BI. So what they wanted to do is that they wanted to collect the data and kind of understand, generate the report saying that how many transactions we are doing per app, those kind of things, but not really geared towards understanding who is stuck in where and what is failing and those kind of things. So just to give an idea, what is the BI solution we are looking at? We have a phone where the SDK is sitting. They send events, whatever the events, like transaction is started or payment is done, etc., etc. It goes to their server sitting in EC2, and it is more of like a log. So there is an hourly push to the S3, which means you have a rolling appender where things are collected and pushed into the S3. And you have two systems here. So this part is a standalone machine sitting and crunching some information, mostly doing aggregations like per app, how many transactions we are doing, just kind of those kind of things. We do have a Google BigQuery sitting, which allows you to do ad hoc querying. Maybe someone in the team want to say, okay, what is happening now? Now means 1 hour before. So that is the ad hoc querying system. Then ultimately, whatever aggregations you do, they end up in MySQL. Right, so this is kind of things what they were already doing, not really complex. Maybe the BigQuery is something new to most of here, but that is very cheap and you can do a lot of ad hoc querying with that. Right, so I think this is the one thing. A single node Spark machine aggregates data by sessions, pushes it to the MySQL. So that's what they were doing. Of course, there are challenges with this solution, otherwise they will not give a consulting job to me. Right? So first one is of course batch processing. Because if you think about any mobile payment, no one is stuck for 1 hour. Right? If you know it's paying after 1 hour, it's not really paying. Right? So it is a more of a batch processing, and when they built it, they never built for a customer. So they built it for their own usage. Because for example, let us say they are integrated with Redbus. One of the common questions Redbus will ask is how many transactions you are doing. Right, to answer those kind of questions, they were built this solution, not really saying, okay, given specific customer is stuck, I want to help them. So that's kind of a thing. So geared towards more report generation oriented flow. Even though you see Spark in the picture, their use of Spark API is very minimal. The reason is that they are not really coming from a data science background, they are more of a mobile developer or a solution developer per se, and it's very minimal Spark API usage. And ultimately, no integration with the mobile SDK, which means you aggregated everything, but it ends up in dashboard. That's all. Your product is not really using these metrics to say, okay, can I do some alerts, saying that if things are failing, I want to give some alerts. The major reason being is the batch processing, because if what do you give after 1 hour? Right, nothing much. So that's where they were in. Now, what are the requirements? The first requirements for a consulting is bring the same calculation what they are already doing on an hourly time into the real time. Right, so this is the first requirement, and I think this is the first requirement of any of the data things where we do. If you already have existing system, maybe doing some calculation, when you move into a new platform, the first thing you want to do is bring whatever is already done into a new system, rather than building a new things immediately. Right, so that is the first thing. The second thing is that, additional to that, understanding user behavior, which means when you think about a payment flow, there are so many different flows you go through, and just to track like where the things are. Of course, the data is already captured, but you want to track the flow. Finally, closing the loop, which means it's not just enough to calculate these things, what you do with it, right? And there are some new specific business cases we thought of, but not really implemented initially. For example, loyalty management. So I will give you just very high level view what we mean here. Let us say I am a really loyal payer. Always I pay things on time, but today I stuck with a payment. Now the company can say, okay, I know you are a loyal customer. I will pay for you. You pay me later. Right? So those kind of things these people can do. The reason is that this mobile SDK is sitting in 40 different applications, and they know you who are through various ways. Ultimately, of course, improving team expertise on Spark also important, because I will be not there forever, and they want to use the Spark to the potential in the future requirements. Now, the first thing you may be thinking, how we choose the different tools. Now, one of the things is that when you think about real-time processing, you have few options. Now, the one we gone with is Spark Streaming. Why we already went with it? The first thing is, since company was already invested in Spark, so Spark Streaming is no-brainer for us, because even though they are using to very small level, but still, since they say, okay, we know Spark, then it says, okay, Spark Streaming makes more sense. But maybe we discussed, okay, what you are using Spark is very minimal, maybe we look for other things because porting may not be too difficult. But why we went with the Spark Streaming, another reason is that they already had a lot of code doing batch processing. And porting into Spark Streaming is very, very easy. Which means if you have a Spark batch processing code, moving into a Spark Streaming really don't take much time. Because they use and behave same way. They have a same API. So this is a very important thing, which means if they really know how to do in batch, you can easily migrate into a real-time thing. So we will see architecturally how we did it. And companies using Python, and Spark has a nice integration to it. Which means if you go to Hadoop, you have to use Java. Right? If you go to Storm, they have their own DSL. If you go to someone else, you have to use some new language. But they were already using Python for backend, front end, so many things. And Spark was giving them that Python thing. They said, okay, Spark means way more better. So ultimately what we did, because of these reasons, we said, okay, we are not considering the Storm, we are going with the Spark Stream. So maybe Storm is much better if you have a really real-time thing and you have a huge amount of data coming, which is not really true. And what we wanted to do is that we want to build things faster because we want to react faster. So which means reusing the existing code and reusing the existing technological understanding like Python is much more important rather than saying, okay, we will going to go to a very high scale things. So that's why we went with the Spark Streaming compared to any other system out there. Okay, now we directly don't move everything to Spark Streaming. There has to be a gradual process where team is involved in understanding how the things are moving so that they understand, okay, this is how our calculations are going to Spark Streaming. We cannot say, okay, just remove everything what we have, let us build something from scratch. So the next few slides, what we are going to discuss is technical details, how we move from a batch processing system into a real processing system like slowly over a time, right? Now the first thing we have done, which is interesting, is that we kept the things very same. We removed Spark and put Spark Streaming. Okay, really if you think about deployment, there is no change. It's the same process running, but the way it runs is different. Spark Streaming is always listening mode. Spark batches that you submit, things are done and you come back. So that's only the change. What we changed is, we took this role appender and we told, rather than doing 1 hour, push every few minutes. That's very easy setting in Log4j and say, okay, rather than doing 1 hour push, do every few minute push. Then what we did is, in the Spark Streaming, there is an API called file stream. But I will talk about this. What exactly is that? What is a file stream is, it allows us to pull a S3 bucket for every few minutes. So what I am trying to say is that it's a still batch processing, but in a very faster way, rather than saying we don't have a queue or a message queue, those kind of things. What we do, we send the data very fast, very few minutes, and we use a file stream API, which is built into Spark, and say, pull this directly for every few minutes. When you get a file, then all the logic what you used to apply for a file continues. Are you able to follow what I am trying to say here? Because if you go to the Storm kind of a system, then you have to build the message queue, then you have to build the whole system. But here, if you think about it, we almost change nothing. We just change the one setting saying that get me data as fast as possible, then we use a file stream API and everything after that remains almost same. So what allowed us this to do is, we build this system within 2 days. Right? Because we still getting the file, the logic operating on the file remains same, the way we get the file little bit changed. The reason is that now we are pulling from every 5 minutes and this is always listening mode, which means every 5 minutes we get few more files and after that the processing remains same and all the downstream applications remain same. Almost no code change and everything remains same. Which means now we moved into 1 hour to 5 minutes with a very little effort. So which means we moved from a batch processing into near real time without much effort. Now this is where the Spark really shines. moving between real-time, batch, interactive is very seamless compared to any other system out there. Okay, then you can say, oh, you cannot be always on the file forever, right? Of course. Then we started, the second version, we started to use Amazon Kinesis. So how many of you heard Kinesis? How many of you heard Kafka? Okay, so many people, right? So I will just give you what the Kinesis is. It's a Kafka-like distributed message queue by Amazon. Okay, very simple to understand. You can think it's a Kafka, but it is a service maintained by Amazon. As simple as that. It's a used managed Kafka source on AWS web service. The reason is that if you see the earlier things, everything is on Amazon. So it's a no-brainer to go with the Kinesis rather than saying we install Kafka and try it using or something, right? So what we did, we just went with the thing, and it's a highly scalable, low latency support. If you know already Kafka, what are the things you know are similar. It has a persistent with a tall forerunner. For example, when the data comes to the Kinesis, they store it in 3 different availability zones. So that even if something goes wrong with one availability zone, you still have the data, which means there is a persistence. And I think the amount of time is 24 hours, which means after the message comes to the queue, it will be there for 24 hours. Even if your streaming is gone down for some time, you can come back and pull and get the data. And the very important factor is it has a great integration with Spark, which means Amazon itself built a SDK which plugs into the Spark where we can connect to it. It's not like a third-party library, it's not like someone else is building it. It's from Amazon itself, which means there's a good integration with Spark. So that's why rather than going with the Kafka, we went with the Kinesis. The reason is that all the infrastructure is maintained by the Amazon. You just have to push the data and get the things done. So what we done as a second version. Now what we done is Amazon Kinesis is added as a real-time stream rather than pushing only to S3. Now also we are pushing to Kinesis. Now the time limit is gone. We are no more thinking 5 minutes. Whenever the data is there, we are pushing it to Kinesis, and it can handle so many megabytes per second. Login server push logs to Kinesis as they arrive. Now what they do is that we moved away from file stream into Kinesis stream. It's a one-line change if you ever work with the Spark, and everything remains same. So which means we were working with a file, now transitioned into a queue without really changing much into the application because they work seamlessly. Now over time we also added this multiple partition support. If you work with the Spark, you know you can have parallel streams where you have multiple topics and pull from that. It's exactly the same on Kinesis, which means if you have data coming from so many different devices, you may want to have multiple partitions rather than having a single stream. Again, this is seamless. It's more of an infrastructure work rather than actual things. Now, you may be skeptic, right? Okay, how can be so smooth? Right? How can be so smooth? So, it is not really smooth from this version along because now we are hitting into real-time things, right? 5 minutes file is still a batch. Now, once you move into a real-time, things start changing. The first thing is, there is a thing with the Python itself. One of the questions normally people ask me is that, when we move to Spark, which language we should go with? That kind of question never comes in any other framework because most of the frameworks only give one language and you have to live with it. But Spark being a nice citizen, what they have done is that they have given support for Scala, Java, Python, and recently they also added R. Now people may ask, okay, should we go with Scala, Java or Python? Normal recommendation from my side is I am a Scala cheerleader kind of a thing. So I say, okay, go with Scala. But no one going to just spend 3 months learning the Scala and using it, right? So what they say is that we are already using Java inside our company. It's no-brainer to go with the Java. Or we are using Python with the already, we will go with the Python. One of the things we hit into is this issue with the Python being a secondary citizen. So what I mean here is that in Spark, Scala is the first citizen API. Which means whenever there is a new API, it first comes in Scala and Java, then it goes to the Python or any other language. So, I told you, right, so March is important. So when we were working, the Spark Streaming API was introduced to Python in Spark 1.2, whereas it was there from point A in Scala and Java. Which means whenever there is a new library comes along, it's always available first in Scala, then slowly it goes to the Python. And as we are already using Python, what we had an issue is, there was no AWS Kinesis connector available for Python. Which means maybe Spark is caught up with the Python, but all the libraries around it they are not really caught up with the Python, which means even the library builders, they first give to Scala, then they slowly build to other languages. So what we got into is that everyone said we are great with the Python, and suddenly we realized, oh, there is no connector to it. Then there was two discussions going on. The first discussion is that, okay, let's go with the Scala. That's what I was saying. But they were saying, okay, better is we build our own connector. That's much easier compared to going with Scala. Right? So what they end up doing is that they end up writing their own connector, because that connector is not really complicated if you want to do the simple things correctly. But I think over a time what happens is that, of course, Python has caught up and have moved into actual official connector. But this is the one thing you have to remember when you choose languages. Right? Any framework, there is always this first citizen API, then there are a few others. Though the company says everyone is same, not really, because there is always limitation of developer time, right? So then also, how many of you heard the Spark job server, where it's a REST API, we submit things, and if you see, there is no Python support for it. I don't even now there may not be, but we found out that there is no Python support, and they end up building their own job servers. Right, so what else is that, this is the few things I wanted to highlight, because if you make a decision on the language, it's not only framework, these surrounding tools, surrounding libraries also becomes a bottleneck. But still after that, now everything is fine, so you can still use Python, but that's very good. Now, challenges from batch to streaming, because when you move from a batch to streaming, the way application behaves also start changing. One of the things what they used to do is that most of the aggregation on their logic is always session based. What do I mean by session here? So let us say you started a payment and you end up payment. So that's a session for a customer, and there's aggregation done, how much time is spent on session, etc., etc. And normally a session can go from 1 to 10 minutes. Right? How many of you can do a 1 minute payment? Maybe we can have a kind of so how many of you seen 4G ad by Airtel? Okay, so they do everything other than payments. Right? You should have one saying that, okay, how fast you can do a payment. I can bet you cannot go with below 1 minute, irrespective of which network you are. Right? So it goes from 1 to 10 minutes. And it was straightforward when you do batch processing, because 1 hour, most of the sessions are completed and you can do some things. But when you are thinking about real time, the data what you have, where the sessions are not yet completed. Right? You have a half sessions where you cannot really start calculating things, where you naturally move into the states. Right? When we do streaming, it's not only purely on a batch basis or a time basis. We also want to do state-wise. Here what I mean, if I have a data for a session which is not yet completed, I want to keep track of it so that when the session is completed, I can start doing some calculations, and that's where the designing of state comes along. Which means you have to think, okay, how we have to design the session, how we have to keep the state. And also, once you have a state, then suddenly you get into checkpoint. Right? Because how big can the state is. Right? Maybe there are some reasons. So one of the things we hit into, right? We had a session which never completed. Now it is there forever in the state. And if you have more and more failures, suddenly your state is so big, it is kind of hitting into the normal processing. Right? So we have to be very careful how long the state will be. It's like a caching kind of a thing, right? So we have to be very careful about it. And once you have a state, you have to think about checkpointing, right? How long we checkpoint, or how frequently we checkpoint, and where we checkpoint, how much we checkpoint. Because as the data grows, the checkpointing data also grows. And also, once checkpointing grows, if the applications is like crashed and come back, time to come back also increases. Right? If you see the simple thing of moving from batch to streaming, suddenly everything is changing. Right? So designing checkpointing and designing an interval is difficult, because checkpointing in Spark is one line of code. Right? It's simple to start, but the amount of details you have to remember is so much. Right? You have to change in configuration, you have to make sure things are fine. One of the weird issue we had is that if you look at our architecture, right? We don't have a cluster in Spark. Right? Because we can handle whatever the things coming in even with a single machine itself. So what happens is that when we want to checkpoint, we have to checkpoint to a storage where things will not go away. Because if you are checkpointing to a local disk of a AWS thing, that may kill it, right? So all your checkpoint state is gone. So what we are doing is that we were checkpointing into S3. Because S3 also is like HDFS, you can just enable S3 and say checkpoint. Now, we started to hit to weird problems. For example, you know S3 is eventually consistent. Now one of the things even I have with a new customer is that you write file to a S3 and immediately ask, does that file exist? You say no. Okay, so this is one of the issue we had. The reason is that after writing the file to S3, it will take some time to be available in all the distributed places. And when you ask, is it exist, it may go and ask any of the places. And if it is not yet replicated, then you can get an answer no. Right, so what happened is that the Spark checkpoints to S3 and it goes back and say, oh, I want to access this now. It says, I don't have any idea of what you are talking about. Right, so over a time we moved into SDFS and those kind of things, we'll talk about that. But if you think about it, enabling into checkpointing into S3 again is one line of code. But after some time you started to hit, and this cannot be solved because Amazon is not going to change this eventual consistency. And that's how they scale. So you have to be aware of other system other than Spark, how they behave. Otherwise you will get into this kind of issues, right? So this is second version where we really started doing real time and we suddenly started to change things rather than saying we are happy with earlier things. Now, okay, so this one another thing. Improvement to the bash code. So how many of you use Spark SQL these days? Okay, so one of the things is that most of the code was written in RDD paradigm initially. The reason is that team only knew map and reduce by key because that's what they learned from MapReduce. So everywhere I can say there was a map and with the 50 lines of code and there was a reduce by key. So, and also in Spark 1 till was Spark 1.1, RDD was only way to do it. Right? There was no other way. But what we have done is that we trained the team on Spark SQL and Spark streaming, which means not only on batch processing, we also trained the team on these two things. Then what we have done is, and this is the trend I am looking across the different customers, majority of code was ported to Spark SQL based solution rather than working with RDD. So no more we see more and more code on RDD. We port most of the things with the Spark SQL. The reason is that we are talking about structured data most of the time here. That maybe there is a JSON data coming from your mobile, data coming from different places, and with the Spark SQL we have schema discovery, etc., etc. So there is no reason you have to write MapReduce code. You just have to write data frame based code or SQL based code, which is easy to understand for anyone, rather than having a 4 map and just say _1_1. That no one knows what does _1 stood for after a few years or even a few months. So then we say better write select star from some table, because ultimately we get the same thing. Right, and also recently I think I heard that they have moved into data frame based code. It's almost same, but it adds some more flexibility. If you are not really know what are these things, to give an analogy, I think everyone done Hive, right? So think like you can do Hive, Pig, MapReduce, Impala, everything in one program, right? That's what we are talking about. So you can write a MapReduce, and next time you can write a SQL. Next line you can write streaming, and next line you can write machine learning, and it runs on one program. Right, so that's why it's easy to implement something on SQL, get the result, implement something on machine learning, and move from there. Right, so if you want to start with the Spark, I encourage you to go to data frames, learn more about it rather than going with the RDD, because if you are not expert, you are not going to end up writing in RDD. Now, there is a third version. Now, if you think about timelines, maybe I told like versions. So I only consulted them for 8 days. Okay, there is a two reason behind that, because there is a money involved. Right, for every new day they have to pay more, and they don't want to pay really, right, because it's a small company. The second thing is that they want to do faster, right? They can't say, oh, we will architect for 3 months and we will have a solution. No, they are saying, okay, let's work for 2 days, we'll see what happens. Right, so first version is 2 days, second version is like 3 days, so we'll keep on improving. The third version, now you cannot just have one machine running Spark streaming, that is too much to one machine. Then we have to go with the cluster. Right, now with the Spark, you have options. Now people say options are great, but not really always, because it creates more confusion, right, what to use. So with Spark, you can go with the local mode, which is like a single machine running. You can go with standalone cluster, which is Akka based framework. You can go with the Yarn. I think most of you know Yarn here. And there is another thing called Mesos, which is kind of like a grandfather of Yarn. Okay, what is Mesos? Mesos is a cluster manager very similar to Yarn. Why I tell you it's very similar to Yarn is most of the ideas are copied from Mesos to the yarn, but they are not really implemented greatly, right? So Mesos is a great cluster manager for Spark only workloads, because here we are talking about a company which is not using Hadoop at all. Their first solution they are building on Spark, and they are not even thinking about introducing any Hadoop components. So which means if you have a workload where you are going to use Spark for everything, then Mesos is a great cluster manager rather than going with the yarn. Now you can think, okay, where the yarn makes sense. If you already have Hive, MapReduce thing running, if you want to introduce Spark into your company, then you can go with the yarn. But if you have a chance to go directly in the Spark, I recommend Mesos. Now why? The first reason is that Mesos has something called coarse grain. What do I mean by it? So I think everyone knows MapReduce here. So when you submit a MapReduce, it creates JVMs for mappers. Right? Everyone agrees. Then you create a JVM for reduces. Right? The creation of JVM takes time. So what is a coarse grain is, because in the real time, even the delay of creating a JVM is big. And if you are thinking about 400 JVMs creation and killing, it takes a long time. So what is a coarse grain is, I can say, you just create 10 different containers and keep it ready. Wherever I have data, I want to reuse those JVMs rather than creating from scratch. And this option is, I think, is not still available on Yarn, but it's there in the Mesos. The another option is that we say fine grain, which is like Yarn. Simple. You create a JVM when you need it, but if you want real time, coarse grain is much better. So you just use a configuration, you enable it, and everything is real time. Third one is minimal overhead compared to Yarn. Now one of the things I was recently discussing with one of the bottom-boss guys is, out of 10 GB of RAM, what you give to a container, there is a 1.3 GB given to something called Yarn overhead. Right? You are just wasting so much of memory. I don't know what the Yarn overhead is, but if you don't give it, it will stop. Right? So, but Mesos, there is no really overhead. Because the way they do it is that they just hand it over everything to you, and internally they use Linux containers, which is a much smaller. If you ever used Docker or something, you know how lightweight it is. Right, so internally Mesos is built upon idea of Linux containers, which means you don't have too much of overhead, which means you can use the resources more effectively compared to a Yarn-based system. And also, this is very easy to set up on EC2. They have script, of course Yarn also have a script, but comparatively this is much more easy. So that's why we went with the Mesos rather than going with anything else out there. Now, finally what we have. So if you see this picture, right, we changed all the things, but we are still living with MySQL. Right? The reason is that everything else is using MySQL, so we thought, let us write everything else also into the MySQL. But all the pieces are going to scale, but does this going to scale? Right? The last piece we changed is that we removed the MySQL and we use something called Grafana. So I'm going to use Graphite here or InfluxDB just for, so what do you use more for monitoring purposes? In your companies? For like seeing like the status of the servers, etc. etc. Sorry? Okay. Splunk, okay.
As well as one more
Datadog, okay. Anyway, so what is a Grafana? It is simple. Grafana is Graphite plus InfluxDB. Think InfluxDB is a time series database. Because when we talk about event data, we are talking about time series data, right? Every few events are having a timestamp, and Graphite is a dashboard kind of system. Think like a library plus framework, where you can build these things. So what happens is that whenever the calculations are done, they are pushed into InfluxDB, because InfluxDB can scale like any NoSQL database, and you do Grafana kind of thing where you can do all the visualization, those kind of things. So moved away from MySQL to time series data because we understood that MySQL is not the right way to store. Scales much better to MySQL, that's very important. Now also one of the reasons why we went with the Grafana and Graphite is that, now one of the things the company told me is that we don't have data scientists and we are not planning to recruit. The reason is that if you want to recruit data scientists, first it's very difficult to find one, and even if you find one, you have to give like 3 times what you give to normal developer. Right, it's a money plus time. So what they told is that we are not going to have a data scientist. That's where it's good for my business also. But what I told is that we want our own people to look at this dashboard and understand what's going on. So that's why we put the real-time system, and always whenever there's a result, we push it to the graph. So which means someone from the product engineering, they can look at these graphs and say, oh, this is working, those kind of things. And also they went to some level. What they used to do is that they make a change into SDK, they push it, then people integrate it, then they go. But it takes like a few months to go. The reason is that they are very worried about maybe something is breaking. Right? When you make a change into SDK, things can change. So what they have done now is that they push the things and they see in the Grafana, saying that is something broken. If it does, they have a dynamic way to switch off that feature and say, okay, now we are switching off for some level till we fix it. So that now what's happening is that you make a change, you immediately within a few hours you will start looking at is there any anomaly, right? Just by looking at these things, because everything is in pipeline now, and if there is something, they push a new change. It is built on JavaScript because so it's very easy to change. Then if something is broken, they can do that rather than hiring someone and say, oh, we have data for 2 years, find out what is wrong. Ultimately, what they have done is that since we have an influx DB sitting with time series data and calculations, they integrated it into the mobile SDK. What happens is that influx DB and Graph8, they do have an alerting system, which means after some time, if something is gone wrong, they can have an alert. That alert will be on dashboard, but that alert will be also pushed into mobile SDK, which means something is going wrong, maybe notify or maybe switch off some options, etc., which is very important because we are closing the loop. And no more people are just dumping the data and saying everything is great, but what will do there?
No SQL completely.
Not really. So this is only for data analysis. The product still uses MySQL. Okay, so it is only for data analysis purpose. Right. So yeah, I think that's all from my side. Right. So the overall architecture, everything is done 10 days, but a lot of these things are evolved over a few months now, and they are running things fine. Okay, so that's all from my side. If you have any questions, you can ask me.
I have a question about your thoughts on application of a particular use case. Okay?
Yeah.
So the use case is not typically for mobile payments, but let's say we have your physical stores, right? So they have this inventory, and let's say there are stockouts in inventory, and there is no real-time way to really capture what is being sold, what is there in my back office, and all. Do you see this architecture in some form or the other fitting into that use case? Considering one factor, the inventory data is huge, which has to be looked up real time every time we do POS transactions.
That's a good question. I am working with one of the customers, not on the retail. What they have is that they have ore mining. Right, and ore mining, normally things will go into different phases, maybe right from digging into the different processing. And the thing is that nothing is captured in the software per se, right? It's all manual and things are there. What they are doing is that they are building IoT based systems which are capturing these sensors. So what I mean here is that let us say one thing is sold, you can have a sensor. So that's what most of the retailers are also doing, is that captures that from the whatever the retail shop and say, oh, something is sold. It pushes the data in the real time. And of course we have this whole inventory sitting up saying that what exactly is sold. So what we do in the Spark arena at least is, Spark is very good at in-memory, and we know that inventory don't change too much for a few days or a few weeks also, right? So what we do is that we pull all this data, or maybe let us say top items what normally get sold, and cache it into memory. And most of the lookups happens that on memory. That's one option. If not, there is a company called Aerospike. If you heard of it, Aerospike is an in-memory NoSQL database which can also hold this in the cluster. Which means most we are moving the lookups into in-memory so that even the data is huge, we don't pay that cost of looking at it. Does that answer the question?
Yeah.
Okay, sure.
So you mentioned about time series database. Like
Yeah.
Did you consider something else like truth? Was that?
Oh yeah. So now this influx DB Graph8 is not really done by me. It is their own people's thing, because I think they were already using Graph8 for their server monitoring. So they already knew these two systems. So that is done by them, not from my recommendation. My understanding of visualization is very small. Right? I don't understand really. Yeah.
How did you take care of session-wise aggregation in real time?
Yeah, so that's a good question. So what we started to do is that every session has a unique key, and it creates a state in Spark. So in the Spark, state is a key value pair, and what we used to do is that we normally get two JSON values and we have a unique ID, and when we get a same session, we do a merge. Okay, so for a unique ID, these are the session information we already got, this is the information we newly got, we make a merge, and in the session there is an indicator saying that session is done. So then we do some processing, window based kind of a thing, then we dump it from the state, which means no more that session is there in the state. So that's what we do it. Any other question? Okay, I think I am on time. Right, okay, thank you guys.